Electrical circuit analysis or circuit analysis subject or circuit theory. In this video, we see Thevenin's theorem, that is BE and BTech students. Anna University and DOT syllabus. 3 units are same. All syllabus in circuit analysis subject seen at Man Engineering link. Man Engineering welcomes you all. Thevenin's theorem. Questions. How obtain Thevenin's sequence circuit? That circuit is shown in notes. That circuit is put A, B, C, D nodes. B or reference node. Kindly note that B or reference node. Dependent current source, that is 2.2 VA. At node A, consider node A. Nodal voltages apply in Thevenin's equivalent circuit. VA, that is node A point, meeting element is 4 and 10 ohm. So VA divided by 10. 10 ohm is dependent on the voltage VA. And 4 ohm is dependent upon the voltage VA and VC, and opposite direction put minus VA minus VC divided by 4 is equal to 0. First equations we found out. Supernode in this circuit. I already explained supernode circuit in nodal voltage analysis. Kindly see at Man Engineering supernode circuit. New classes as 2026 year. This year, new classes 1 to 60 classes. In 1 to 60 classes, nodal analysis supernode circuits I explained. Kindly see that classes. Supernode CD. Consider a D point 6 ohm and 4 ohm are meeting element and 12 volts supply and 0.2 VA dependent current source. First consider 0.2 VA supply. 6 ohm resistance is dependent on the voltage VD. VD divided by 6 plus 4 ohm resistance is dependent upon the voltage VD and VC. So VD minus VC. VC is opposite minus VC is equal to 0.2 VA. We find it second equations. And 12 volt supply is put VC minus VD. So VD is minus directions is equal to 12, third equations. As well supernode circuits previous classes. From this equation we obtain VD is VC minus 12, third equations. Solve 1 and 2 equations. Side portions are given first equation and second equation solving method. From first and second equations only find out 7 VA minus 5 VC is equal to 0, first equation. Minus 1.2 VA plus VC is equal to 30 is second equations. From first and second form mesh matrix 7 minus 5 minus 1.21 VA VC is equal to 0, 12. B is reference point, that is reference point voltage is 0 volt. So not calculated. VA and VC is calculated only in this method. Solve the equations. Put nodal point first, A, B, C, D. B is reference point. Consider node A form equations. And consider supernode form second and third equations. Solving first and second, third equations, we find out 2 equations. From 2 equations form matrix former. Matrix former shown that page. The matrix mathematical function, we find out VA, VC value. Take 2 by 2 matrix, right side inverse matrix. VA, VC is equal to 7 minus 5 minus 1.21 inverse matrix into 0, 12 matrix. Find out determinant value matrix and cofactor value matrix. Only find multiplication of matrix and then find divided by determinant value. Only we find out VA and VC value. VA is 15 volt, VC is 844. VA is from circuit. VA value is V Thevenin value, that is VAB, open circuit voltage. Thevenin steps I already explained. Remove the position of the circuit. I already explained Thevenin steps. Remove the position of the circuit across which terminus equivalent circuit is to be found. Mark the terminus AB of the remaining two terminals. That is, VAB is terminal V Thevenin voltage. That is open circuit voltage, 15 volt. We find it by mesh method. That is, V is IR. That is applied in this method. Next format, we find out RTH, Thevenin's value. RThevenin dead source circuit, that is zero voltage sources, we find out Thevenin. In this circuit, differently find out Thevenin value. From circuit first formula find out. RTH is VAB divided by IAB. VAB is open circuit voltage divided by IAB short circuit current. That is important point. Not dead source circuit found out. Only 12 volt supply we found out. In this 12 volt supply circuit, IAB is V divided by R. That is, V is 12 divided by R is 10. The above circuits one is resistance 10 consider. 6 ohm is 0 resistance. Consider not consider 0.2 volt. That is considered 0 and 6 ohm is 0 resistance. IAB is found out from above circuit 1.2 ampere. That's short circuit current circuit. Short circuit current operated from circuit. From this IAB and VAB value, we find out RTH is V divided by I. We found out. Kindly noted in this model circuit, we find out Thevenin from not zero voltage sources. Circuit is put. Only we put short circuit. One is 12 volt supply circuit. One is 10 ohm resistance is considered. 6 ohm is 0 resistance. 0.2 is 0 sources. From this circuit, we obtain IAB. Short circuit current is V divided by O, 12 divided by 10. That is 1.2 ampere. RTH formula is VAB is open circuit voltage divided by IAB is short circuit current. That formula is important for Thevenin find out. We see Thevenin is VAB divided by IAB. That is, already we found out VAB is in matrix procedure 15 volt divided by above circuit IAB value is short circuit current 1.2 ampere. RTH is V divided by I 12.5 ohm. This is Thevenin sequence circuit. We find out put 15 volt and 12.5 ohm resistance. That is VTH and RTH is form this Thevenin sequence circuit. That is answer circuit. Again, I explain for procedure. Consider the circuit A, B, C, D node. B is reference point. Reference point voltage is 0 volt. And put nodal analysis method and node A form equations and super node DC is for two equations form. From these equations, we find out VA and VAB value, this Thevenin's value. Then form short circuit. From the short circuit, we find out short circuit current value. From short circuit current value, we find out Thevenin is VAB open circuit divided by IAB short circuit current. From this, in the short circuits, 6 is dead resistance, 0.2 is 0 sources considered. From Thevenin value, we find out from VAB and IAB value, find out RTH value. From RTH and VTH value, form Thevenin sequence circuit. Mesh current analysis method apply and nodal voltage method apply. Ohm's law apply. And short circuit current and open circuit voltage is used. RTH is find out. ETH find out for matrix format. This is procedure Finally, we find the RThevenin and VThevenin. This is the Thevenin's equivalent circuit. This is simple procedure for nodal analysis method of Thevenin's equivalent circuit. Find out. And engineering, thank you.